Hello and welcome to this video titled An Overview of UDP. In this video I'm going to cover an introduction to UDP. What is it? What benefits does it do for us? Why do we need it? And we're going to talk about something called transport layer port numbers and how those port numbers work in a session of UDP. So let's start with UDP. UDP stands for the User Datagram Protocol. Now, why do we need it? Let's back up here for a second. All right, so in order to explain this, I want to show you something amazing. You ready for this? Look at that. Wow, 3 tabs of Google. I bet you've never seen that before. Okay, but there's a reason why I'm showing this to you. So if you've learned anything about IP addresses, and forget about IP addresses, let's just say IP, the Internet Protocol. So imagine for a moment that this tab right here was going to send a packet to Google. All right? Now, I don't know necessarily what address that is. Let's just make it up. Let's say the destination is 8.8.8.8. Okay? Now, in the IP header, one of the fields in the IP header was called the protocol field. The protocol field. And that field carries some number to indicate what IP version 4 is carrying, what kind of data is IP version 4 carrying. Now let's say, now this is not the way it works, but let's say the protocol field said, oh, I'm carrying HTTP. This is from a web browser. Okay, so remember, it's coming from this tab right here in Google, and let's say in that tab, I'm searching on the word cat. All right, sorry for all you cat haters out there, but let's say I'm searching on cat. All right, well, and this is coming from me. Maybe I am 50.1.1.1. All right, that's my source. Well, here's the big question. All right, that gets to Google. That gets to some web server located at 8.8.8.8, and that server is running HTTP, so it says, oh, okay, this is HTTP. So it strips off the IP header, sees my lookup request saying, hey, Google, show me all web pages that have anything to do with cat. And then it sends me a response back. All right, here comes the response. Now the response is coming back to me. It's going back to 50.1.1.1. And in the IP protocol field, now remember, this is not the way it works. I'm showing you why we need UDP. The IP protocol field says HTTP. Uh-oh, we got a problem here. Because aren't I running 3 tabs of HTTP? How is my web browser going to know that the cat responses are supposed to go here as opposed to here or here? Well, if all we had was the IP header, we couldn't answer that question. There's no way to answer that. So what we need is we need something that, yeah, here's my, let's do this. Here's my IP header. So let's say once again, let's do this tab this time. So I type in cat into the search field. All right, so the source here is going to be from me. Let's just assume I'm 50.1.1.1. The destination is going to be Google. Once again, we're just making up an address here. All right. And there's going to be a protocol field here. Let's just leave that alone for just a moment. So now what we need is we need another header behind this. A header that has 2 unique numbers. One unique number says, hey Google, destination, I'm talking to you. I'm talking to HTTP. I'm talking to your HTTP process because who knows, maybe 8888 is running other types of applications above and beyond HTTP. So HTTP is what I need to talk to. And we need, as far as source here, why don't we have this tab come up with a unique random number like 7,000. And anything that's generated from this tab is a different random number. Let's say that's 8,100. And this tab here, any search I do on there is 9,400. So if my search is being generated from this tab right here, I'll put that in this field. So we need another header here. And this is where TCP and UDP come into play. TCP and UDP, now I know this video is specifically about UDP, but one thing they both have in common is they now say, hey look, if you're running multiple instances of the exact same protocol like HTTP in this case, we'll be able to create unique session numbers for each one. Our header, because IP header can't do this for you, our layer 4 header, our TCP or UDP header, will give you unique port numbers that you can use to differentiate. So now when the reply comes back, okay, the reply will say, hey, destination, I'm talking to you, 50.1.1.1. This is coming from me, from Google. I'm giving you back what you wanted. Oh, and in that layer 4 header, the destination is 7,000. Now, this tab will know to generate the response in order to show me what Google is telling me. So that's why we need a header after the IP header to be able to differentiate different sessions. Now let's go specifically to UDP and see how UDP handles this. So UDP is the user datagram protocol. This gives us a header after the IP header that basically all the UDP header does is give us those source and destination port numbers that we'll talk more about here in just a moment. So this is documented in RFC 768 if you want to go into the details of that. Now UDP, just like its big brother IP, is connectionless. Once again, meaning that IP and UDP, one thing they have in common is when you use the services of those protocols, there's nothing in there to dictate whether the destination you're trying to reach is alive, or if he is alive, if he wants to talk to you, if he's running the same application that you are. When you send data to him, did he actually get it or not? In a connectionless protocol, we don't get answers to those questions. A protocol that is connectionless says, hey look, I'll take your data, I'll stick a header on it that's appropriate for putting it into the network. After that, my job is done. I don't care if it got there or not. I did my job to just send it out on its way. UDP is connectionless. And the UDP header, as I mentioned, is placed right after the IP header. So here is our, if we just sort of imagine this, this might be our Ethernet headers. If we're running on Ethernet at layer 2, this might be our IP header. Now in the IP header we had the protocol field, and the protocol field is going to have a number that's going to indicate it's carrying UDP, which is going to be the number 17. So IP protocol value 17 says what comes next is a UDP header. Well, what's in the UDP header? Well, what comes after the IP header, in this case, if we're talking UDP, is the source port. So like in my example, this would be a random source port number that my particular tab of my browser created for its own session. A destination port number, and we'll talk more about that in just 1 second. The length of the header plus the data, a UDP checksum, and then the payload. The payload in this case would be HTTP, whatever my HTTP request or my HTTP response happens to be. So you see, UDP, really all we're getting out of it as useful fields are the source and destination port numbers, which enables us to track unique sessions of the exact same application that's running simultaneously on our computer. All right, so let's dig a little bit more into those port numbers and see how they work. So TCP and UDP both utilize port numbers. So these are logical entities. In other words, they come and they go. If I shut down a particular tab of my browser, whatever port number was associated with that tab is now going to be released and not used anymore. Now maybe some other application could use that same port number. So it's used by end system applications to bind their transport sessions. Every TCP UDP segment or datagram has a combination of a source port number and a destination. And we'll see how that works here in just a second. Now, from your laptop's perspective, from your tablet or smartphone's perspective, when it's creating a packet, because you're browsing the web or you're trying to reach out to some instant messaging service or something like that, the destination port number will be a well-known registered port number for that particular service. For example, there's a well-known port number for HTTP, web browsing. There's another well-known port number for email and all sorts of other stuff. The source port number will typically be something that's randomly derived. Now, these two bullet points here, once again, are specifically from the reference point of the host, the laptop or PC that's generating a request going to a server. So as far as port numbers are concerned, the Internet Assigned Numbers Authority has divided them into 3 distinct ranges. Ports 0 through 1023 are used for common, well-known services. 1024 through 49,151 are what's called registered ports. And then everything above and beyond that are random dynamic ports, what we sometimes call ephemeral ports. All right, let's actually see how this works. How port numbers work. Step number 1. So we've got a server on the right and a laptop on the left. So step number 1 is somebody's going to get on that server at 10.222 and start up some service, like maybe a web browsing service or a telnet service. So whatever they start up, that service, that application is going to bind to a well-known port number. So let's say that we want that server on the right to be a telnet server. We want people to be able to log into it and then actually issue commands on it and get responses back. Well, telnet has a well-known port number of 23. So now that server is going to say, okay, I'm now listening on that port number. If somebody sends me a request and the request is going to 23, I can respond to that. Now, if somebody sends him a request and the destination is port number 1006, he'll say, well, I don't know what that application is. Whatever it is, I'm not running that. I'm not listening to it. But he is listening to 23 because that's a well-known port number. That's in that well-known space that's reserved for telnet. Okay, now the laptop comes along and says, hey, I actually want to initiate a telnet session. Okay, so he says, all right, well, if I want a telnet session, I need to be able to track that because maybe I have more than one telnet session. I could have like 3 or 4 telnet sessions going from this exact host of 10.111 going to that exact same server of 10.222. There's nothing preventing me from doing that. So I could have one telnet session right here, another telnet session, and a third telnet session. All from the same host going to the same destination. And so when a reply comes back, we have to know, is that reply with the first session? Is it a reply to the second session? Is it to the third session? So that's why we need to have unique random source port numbers to keep track of these sessions. So for this initial session, in this particular example right here, the laptop on the left is going to pull a random ephemeral port number from that last range of ports. In this case, he's going to pull 50,000. So now he creates his telnet packet. So notice in the telnet packet what we have here. In the IP header, we've got the destination of 10.222. We've got the source of where it's coming from, 10.111. We've got that. And then in the TCP or UDP header, because they both use port numbers, now in this case it's telnet, so it's going to be TCP. But even if this was UDP, some UDP application, this theory would hold true. The destination port number is the well-known port number that the server is already listening on. The source port number is this random source port number that the PC generated for this particular session. And now when that server responds, he's just going to do everything in reverse. You can see in the IP header, the source and destinations are reversed. And the TCP header, the source and destination port numbers are reversed. And this is how we use port numbers to keep track of individual sessions of applications. So that concludes this video. Thank you for watching.